So I'm going to go back and I'm going to make a cell that is a schematic. I'm going to call it 100FF, little f for femto, big F for farad. Hit OK. Then I'm going to go over here to components, and you know what? I want my, and many of you didn't do this, I want what I draw to be similar in size to what I have in my schematic library. So if I put an NMOS, for example, in a schematic, and I've drawn an NMOS that's a series of 5 transistors, that they're the same size. So I'm going to go ahead, just for reference, I'm going to drop, or if I make an inverter, the symbol I have for the inverter is the same size as what I drew, so I don't have some big symbols and some small symbols. Okay, so let's delete that. Go over here, I'm going to drop that in. Hit fit, 100 millifarads it looks like. Now what? Artwork? Oh yeah. And let's see, what should we use? Let's see what happens. You know what, let's go ahead and drop this in there just to get a similar size. Fit, press Y, move this down, move this up. Fit, expand, and then go back up. Oops. Control Z. Let's do this. Let's make it easy on me. Control copy, Control V, and edit. Mirror. And close enough. Doesn't look out of place, right? Then I'm going to go put on here what? I can put a thick line. Yeah, I want one to be thick, so why don't I try, well, I guess I could click this and make it thick, but the problem with that is it makes the whole thing thick. So I could go over here and see what I can do with that. Oh, well, nothing's happening there. What do I do to get a thick line? Grab this, put this down, fit, and you know, whoops, and of course you can think of, oh, you really didn't need to, you could do other things here, but let's go ahead and delete, Y. Let's do a Control I, and I want it to be thicker. So, attributes. I wonder if it's Y size, art, color and pattern. I think I'm missing some stuff on this small screen. We'll just leave it to that. You can tell what it is. Okay, that's the thicker line. Let's do a fit, expand. Yeah, that looks pretty good. Now what? Yep. You can go throw some spice code in there. And let's make it pretty. Make sure that's spice code. So why don't we go C 100F, and let's not confuse it. Let's just call it C1. Left, or let's be smart. Let's go poly1, poly2, and 100F. I'm going to modify this in a moment. Let's move that over a little. Now what? Yeah, I need to put some pins in there, right? So I need to export those pins. So Control E, and that I'm going to call what? P1. And this one I'll call, what a surprise, P2. Fit. And let's see how many errors I have. None. Hey. Alright, but wait a sec. Oops. Before I do the layout, which is the whole thing, I said there was a big parasitic capacitance from poly1 to substrate. Right? Now, I can add that capacitance in the symbol in many ways, but before I go back, let's see how big that capacitance is. So from poly 2 to poly 1 is 880 attofarads. From poly to substrate is 85, so it's about 10% of the size. So should I waste a lot of mental energy in trying to get an exact value here? No. Okay, so I'm going to put 10%. I can go over here and I can do this. I can do a control I, multi-line, C2, P1, 0, 10 femto. Oops. Okay, I can move that up. I can reduce the size of this so that it's not so invasive. Or actually, let's do this. Let's go 2.5, apply, okay. And I see it's small, and then I can go put what on there? Annotation text, and I can put control I, 100 femto. Good enough. Like that, and I can make this even smaller so I can't see it. I could do one other thing here. What could I do? I could go in here and I could put another pin, and I could make this pin the substrate. I could do a control E and say, oh, that's B, and then I could come up here and go in and say that goes to B. So if I put it and I want to model the substrate noise, I can now put a connection to B, and that models an injection of substrate into the capacitor for modeling. Now you all look at it at this point, but what I'm trying to give you is like, why would I want to do any of that? I want to give you the tools so that when you go on to an advanced class and you're doing a pipeline A to D converter or something like that, and you say, well, how does substrate noise? Well, now you know I'm going to tie all my substrates and my capacitors or my nodes to some value, and then I can put noise on that value, and I can see how the behavior of the data converter changes. We don't need to worry about this. We're doing digital. Life is good. So let's go ahead and delete this. Go back here. And single line. Whoops. Yeah? You want to put that in? Let's put that in just to model it. Yay? All right. C2. I think that's a good idea, actually. 10 femto, because that ends up being a power waster, because I got to charge that capacitance up every time. All right, we're ready for the layout. Okay, so let's save that. Let's go do a control N. 100 F. Yeah. Yep. And then I'm going to go back over here to my exploder. And I said that on purpose, by the way. If you remember when the Ford Explorers were blowing up and everybody started calling them exploders. Okay, so let's do this. Control C, go back over here. Control V, just drop it down. I'm going to make it a little bigger because generally I found that the layout's bigger than the schematic. Okay, now what? Need to go to pure layer, poly. Let's do cap node. I don't remember if that does what I think it does or not. No, oh well. We'll go pure, and then a polysilicon node. Let's do a control I. Yeah, let's center it. 0, 0. We'll play around later. And then what was the size? Let's go 150, because poly has to be bigger, right? 150. Fit. Ah, there's my capacitance. I need to make that much bigger. Let's go 20. Apply. And that's a little too big. Okay. Move that out of the way. Then I'm going to go drop down my capacitor. Control I. And this one I want to be 140 by 140. And let's go 0 by 0. Looking good. There's several ways I can do it at this point. I'm going to do it where I move this over and see if, oops, let's do this first. Let's DRC that and see if we get an error. Nope, no errors. Now let's move it over. Now let me just tell you one thing. Well, I'll tell you lots of things, but I'll tell you something. All right, here, it's like, can I borrow that for a sec? Yeah, just don't give it back. Okay. In some processes, you can't put a poly contact over the thin oxide between a poly-poly capacitor. Okay, so I can't drop a contact down in here. They make you do it over the field region, so I can only connect over here and over here. In other processes, you can connect over here, and you can connect over the thin oxide. So what I'm curious is, what are the setups here? I think that you can have the polys overlap. You can. So now I'm going to make a connection to them. But first, is this the right size capacitor? No, because I know that this overlap is 100 femtofarads. Okay, now you can actually go into the setups and have electric calculate the parasitic capacitance there, but I don't feel comfortable doing that, so I don't. So what I'm going to do is I'm going to select the poly 1, go back over, and I'm going to make my X size a little longer. Let's say, why don't I make that 70, and then why don't I make that 20 and apply. Oh yeah, it's almost like I know what I'm doing. Well, not quite, but let's go there. And now what about, let's move this over. Oops. Yeah. Let's go 10, apply. And what about this contact over here? Well, let's do it the simple way. Let's put our poly1-poly2 contact down. I'm going to do something stupid here, or not good. There's my contact to the capacitor. Alright, so let's fix it. Control I. Let's go Y size 100. So easy, right? And I need a piece of metal. Pull it over. Control I. What's that? You can't connect to a pure layer. So, oops, let me select this now. So that's why I have that text in there for the spice code. What did I say? 100? Oops, I don't want it extending neither end. Okay? You can set it to the default, I think, in your preferences. Let's do a DRC. 2 errors. I bet they're associated with this little thing down here, but let's find out. Spacing a polysilicon node, poly 1 pin overlaps. Oh, that's right. I made the same error last time I did the capacitor. So let's fix that. And then let's do a control I. And then Y size 140. Whoops. X size 140. Or actually, we needed what? 180? 170?
So the problem with your metal with the poly contact is not.
Oops. Control Z. Yeah, it wasn't connected over. Oops. Right. Yeah. Oops, where am I selected there? Control I. Oh, width. Okay. 170. And either end. Now it's connected, and I can actually have it extend over here if I want to. Could have it extend out. Let's see. Oh yeah, can't go through the day without that, huh? All right. So let's go over here and put our poly. Oh wait, how do I get a poly 2 contact? I don't see one here. Pure? Ah, someone said it, but hold on. Let's go to pure. Poly 2. Oh no, there isn't. So what I'm going to do, so you need to know this if I ask you to lay one out. What's that? This one? That's metal 1, metal 2. Or metal 2, metal 3. So here, I'm going to click on this. Then I'm going to press change. That is a poly1-poly metal 1 contact. So that's this right here. So, right there. Then now you need to know this because it took me a little pain to figure this out. Hit change. Then I'm going to change it to a metal 1 to poly 2 contact, or poly 2 contact. Apply. Done. And then I'm going to go over here, delete that. Okay, well, pull it over. I accidentally moved back here, so oops, Control Z. Let's do that again. Stop connecting. You're not smart. Okay, Control I, 140, either end. Okay, yeah, we need to move that over. Move this. Move that back over here. Yeah, DRC fit. You get the idea. Now, what would I want to do? Yeah, Control I, 135 or whatever, who knows. Now, what's the last thing I need to do? Well, I mean, I haven't done a thorough job on measuring the overlaps, because this area here should be 140 by 140, right? Okay, so I need to go over here and Control E, key 2, Control E, key 1. Looking good? Now, I don't know if I've done it right. I may have to label this node. I may have to go in here and double click on this and call it poly or P2 or P1. So what I'm going to do is I'm going to press S and I'm going to write to the desktop this spice file, and it's going to tell me exactly what I'm doing. Let's see, do I have and we'll just do this, it'll give me error. Okay, so it said multiple instances of C1. Okay, it's extracting the capacitance. Yeah, but it shouldn't be this bad. Oh, it's only 8.85. All right. Yeah, so this is just extracting parasitics to ground, it looks like. So I can turn that off. Let's go ahead and do that and then resimulate. Let's go turn to preferences. Where do I do that? Let's do it again. And up here, tells me exactly what I have. Is that what I want on my net list? If I wanted to do it even better, I'd go and place it in a higher ranking cell and connect it up and label it, and then I'd look at the net list to make sure what I did, because this is a non-standard thing in electric, is working right. Does anybody have any questions on how we did this? Or how, if I were to now ask you, lay out an RC circuit, you would go through, we've got 2 minutes left, so let's go and do a new cell. I guess no quiz today, huh? If I go through here and I do a RC circuit, and then I drag my layout in here, Control J a few times, and then show, oops, a couple more, because I want that, fit, expand, go show my ground, making connection. I'd probably make this smaller and put annotation text so that it's easier to see. Come up here and do my N-well resistor. And over here, there. And then I could export this node, or I can just drag it over here and call this VN. Control, and let's put a off-page node. And we should do that for the other one too. Yeah, that's going to give me an error, right? Oh, it doesn't mind. Okay, so, and then I can export this, and then last but not least, one error, show me, delete, no errors. All right, so there I've laid it. I've done the schematic for an RC circuit and an actual N-well resistor and capacitor. I go over and I do the new cell. I do it RC_CKT layout. And then I come over here and since we're out of time, I'll just drag it in there and Control J a few times. Fit, show me, there, and then I could connect this to ground if I wanted. Of course, I wouldn't want the extension. And then last but not least, pull this over, fit, show me, and then drag it over and make a connection. And now I'm getting a circuit which is, this bothers me. And I could put the pins on and all that stuff. I can move this around so it's a little nicer. Any questions? Yes?
On the next assignment, you said you want to connect around our gates or pads that we pads.
Just use the pad you used before.
So 75 micron pad.
Yeah. So you're going to have these little bitty layout and then a huge big number of pads. And then the body's going to be connected to a pad because you have to have it so you can do the body effect.
If we were making 12 pads, I think I remember you saying that minimum size pad would be
Yeah, somewhere, and that depends on the process.
And if that's the case, what it said that the input glass layer needs to be 6 microns from.
And that guy that wrote the book doesn't know what he's talking about. Depends on the process. It's all different for different things. So that's why I don't want to do probe pads right now. Just use the regular pads. Have a good weekend. We'll see you on Monday.